These are the last two examples from our Chapter 2.3 lecture. I want to do the examples on binary base system. There's a couple of homework problems related to that. So this is from your note sheet that I gave you. And so what we need to know is compared to base 10, base 2. So you might want to get this down. Base 2 is a place value number system also, and the difference between base 2 and base 10 would be the base. And so the place values have different values, obviously. So the first one is still going to be the 1's position, and the next one would be the 2's position. And what we're doing is we're increasing by powers of 2, so it's the 4, 8, 16, 32, and it would continue on. Now, where do those numbers come from? This is 2 to the power of 0. This is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and 2 to the power of 5. And so these bases with these exponents produce these place values. So just looking at this first example, so we'll keep that in mind there. We're only going to do example A. We don't need base 8 or base 12. Let's just work with base 2. What would this number be? 1, 1, 0, 1, 1. And what we do is align it up to the right. I see 5 digits here. And so then we put the digits in there. And so it would be 1, 1, 0, 1, 1 in base 2. And so what we need to know is that this is like base 5 and base 10, and that these are positional. Place value has a value. In base 2, the only digits in base 2, the digits in base 2 are 1s. 1 and 0 are the digits for that. So you want to make sure we know that. And so those are only numbers that will appear in a base 2 number, 1s and 0s. And so what does 1, 1, 0, 1, 1 equal? It's going to be equal to, put it in its right place, this one. It's 1 group of 16. Plus 1 group of an 8, plus 0 groups of 4, plus 1 group of a 2, plus 1 group of a 1, and then we add that up together. So you end up with 16 plus 8 plus 0 plus 2 plus 1. So 1, 1, 0, 1, 1 in base 2 is equal to 24, 26, 27 in base 10. Remember, we don't write the little 10, but that's base 10. And so that's what we have there. And so that's how we use the expanded form for base 2. And then looking at the last question here, it's kind of a challenge question, is what is 53 in base 2? So what would 53 be equal to? And so what we ask ourselves are, ask ourselves the question. It's kind of like using the blocks. The problem is we don't have blocks in base 5 like we do with base 5. And so we kind of have to visualize it and think about how many 32s go into 53. And so when I think about what that would be, I would then have a place value system here. Let's put this so we can actually see them. Again, it's the 1's place, 2, 4, 8, 16, 32. And so what's going on in my head is I need 1 group of 32 inside of 53, right? So what does that equal to? So then I do 53 minus 32 since I used up 1 group. And so what's left over is 19. How many 16s go into 19? That would be 1 group. And so then I'm going to subtract 16. And then I'm left with 3. How many 8s go into 3? 0. How many 4s go into 3? 0. How many 2s go into 3? There's 1. So then we would end up subtracting 2, remainder 1, 1 left. How many 1s go into 1? 1. And so there's our answer. What we find out is 53 is equal to, 53 in base 10 is equal to 1, 1, 0, 0, 1, 1 in base 2. That's it. Hopefully you get those homework problems done.